Section 9-1 is on graphing quadratic functions. Now, a quadratic function is a function that has the form y equals ax squared plus bx plus c, where a is not equal to 0. Because if a were equal to 0, then this whole term here, ax squared, would be 0, and we wouldn't really have a quadratic, we'd just have a linear function. Now, the ax squared plus bx plus c part should look familiar from the last chapter where we factored trinomials that look like that. Now we're going to see what this looks like when we graph it on the coordinate plane. So the shape of its graph is going to be a parabola. It's either going to be opening upward or opening downward. It has symmetry. It is symmetric about a vertical line called the axis of symmetry. So this pink vertical line right here is the axis of symmetry. In other words, if I could take 1/2 of the parabola, let's say this half on the right, and fold it over the line of symmetry, it would end up on itself over here. Now I know my sketch doesn't look like it, but when we graph it, it will look symmetric. So this is a line, so it has an equation. The equation of this line, so the equation of the axis of symmetry, is x equals negative b over 2a. And you'll need to memorize that because I'm going to ask you to find the equation of the axis of symmetry. The axis of symmetry intersects the parabola at its vertex, and the vertex is either the highest or the lowest point of the graph. If a is greater than 0, where a is the coefficient of x squared, so if a is a positive number, then the vertex is a minimum and the parabola opens upward. So if a is positive, the parabola looks like a smiley face. It looks positive, and you'll notice the lowest point here, the vertex, is at the bottom, and it's called a minimum. If a is less than 0, that is, if the coefficient of x squared is a negative number, then the vertex is a maximum and the graph opens downward. So if a is a negative number, it looks more like a frown, which when you're in kind of a negative mood, you're frowning, okay? The vertex in this case is going to be the highest point on the graph, and we call that a maximum. So for each function, I want you to do the 7 following steps. Find the equation of the axis of symmetry, find the vertex, determine whether the vertex is a maximum or a minimum value, find the y-intercept, make a table of values, graph the function, and then state the domain and range. So for tonight's homework, you'll be choosing certain problems. I think I've assigned 4 problems out of the textbook, but don't follow the directions in the textbook. Do these 7 things for each of the functions that I give you for homework tonight. So let's take a look at a couple examples here. So we have the function y equals x squared plus 2x minus 1. The first thing I would like to do is identify what are a, b, and c. A is the coefficient of x squared, and since there isn't a number in front, that's going to be a 1. B is the coefficient of x, and that's 2. And c is the constant value all by itself on the end here, and that's negative 1. So to find the equation of the axis of symmetry, which I believe was the first thing I asked you to do, we're going to use the formula x equals negative b over 2a, or x equals negative 2 over 2 times 1, or negative 2 over 2, or a negative 1. Now, do not box negative 1. Negative 1 is just a number. This is the equation of a line. So you need to write it as x equals negative 1. And that's the axis of symmetry. I'm going to abbreviate here. Oops. That's the equation of the axis of symmetry. Next thing we need to do is to find the vertex. Okay? Because the vertex is a point on the axis of symmetry, I know that the x-coordinate of the vertex is negative 1. So the x-coordinate of the vertex is whatever that is right there. So to find the y-coordinate of the vertex, I'm going to take my equation, y equals x squared plus 2x minus 1, and I'm going to plug in -1 for x. So y equals a -1 squared plus 2 times -1 minus 1. -1 squared is 1, 2 times -1 is a -2, and minus 1. And that's going to give me y equals -2. So my vertex is the point -1, and when I plugged in -1, I got my y is -2. So that's my vertex. Part C. Since a is greater than 0, okay, my graph is going to look like this, and I actually like to draw it. My vertex is going to be down there, so my vertex is a minimum because it's the lowest point on the graph. Okay. Now to find the y-intercept, I'm going to let x equal 0 and then find y. So y equals 0 squared plus 2 times 0 minus 1, or y is equal to -1. And that's my y-intercept. Next thing I want to do is make a table of values. And this is the part that gets a little more complicated. So I'm going to draw something that looks like this. Well, let's see, what letter am I up to? Call this is E. Okay, so I'm going to do an X column. And then in the middle, I'm going to put what y equals. Y equals x squared. Oops, that should be a plus 2x minus 1. And then I'm going to calculate what y is. And I want you to plug in 5 numbers for x. Well, how do you know which x's to plug in? What you're going to do is take the coordinates of your vertex, which were -1 and 2, and you already know that those are points on the graph. I want you to put those in the middle of the table. When x is -1, oops, I already know that y is -2. Now I want 2 points to the left of -1 on the x-axis and 2 points to the right of -1 on the x-axis. So I'm going to choose the numbers -2 and -3, because those are two numbers that are smaller than -1, and 0 and 1, and those are two numbers that are bigger. Now I have to plug those in. And I'm not going to write out all of the steps, so we're going to do part of this in our head. So when x is -3, -3 squared is 9, and then -3 times 2 is going to be a -6, and minus 1, and that's going to give me y equals 2. When x is -2, -2 squared is 4, -2 times 2 is a -4, minus 1, and that gives me a -1. And I don't have to do -1 when x is -1, because I already did that to find my vertex. Now when x is 0, this one's easy. I'm going to have 0 plus 0 minus 1, and that gives me a -1. And when x is 1, 1 squared is 1, 1 times 2 is a positive 2, and then minus 1 is going to give me y equals 2. Now, because the graph is symmetric about the axis of symmetry and around the vertex, you should see symmetry in your y values. So my first y is a 2, and my last y is a 2. The next two y's are -1s, and then I have -2 in the middle here. If you don't get that kind of symmetry, you either have the wrong vertex, or you've plugged in the numbers wrong and come up with the wrong value. Okay, now let's graph those points. I'll do it in pink. So -3 positive 2, negative 2, negative 1, negative 1, negative 2, 0, negative 1, and the point 1, 2. Connect to those lines, make it look curvy, put arrows on the end, and that's the graph of your function. Notice, here's my vertex, it's a minimum, okay, and my graph is opening upward. Now let's find the domain and range. Remember, the domain is what can x be? Well, I could have picked any numbers for x. So x is going to be the set of all x such that x is a real number. And my range is what y can be. And this is actually going to be a little bit trickier. So what you want to do is basically take your highest or lowest point, and in this case I have my vertex is a minimum, and notice the graph is going up from there. So my range is going to be any y value that's greater than negative 2, because right here at the vertex y is negative 2, and my graph is going up, so y is going to be all y's that are greater than or equal to negative 2. And I believe those are all of the steps for graphing this function, and that's what I want to see in your homework, all of these different steps. I believe this was actually the 6th step, and this one was the 7th. Green. I'm in green. I didn't realize that. Okay. Okay. Let's try another one. Here we have the function y equals negative 3x plus, negative 3x squared plus 6x minus 1. Let's identify our a, b, and c. A is negative 3, b is 6, and c is negative 1. Maybe you noticed in the last problem we didn't do anything with c. Well, not in this section, we will later on use c. Okay, so let's find our equation of the axis of symmetry. X equals negative b over 2a, or x is equal to negative 6 over 2 times negative 3, which gives me negative 6 over negative 6, or 1. So my axis of symmetry, equation of the axis of symmetry, is x equals 1. And remember, that's the equation of a vertical line. Now let's find the vertex. To find the vertex, I'm going to take this 1, let x equal 1, and plug it into my function. So y equals negative 3 times 1 squared plus 6 times 1 minus 1. Now, this is a little tricky. Remember PEMDAS. PEMDAS says you have to evaluate exponents before you multiply. So do not multiply negative 3 times 1 and then square it. You want to do the squared first. So square negative 1 and then multiply it by negative 3. So 1 squared is 1 times negative 3, gives me a negative 3, plus 6 minus 1. So y is equal to 2. So my vertex is the ordered pair 1, which I got from my axis of symmetry, and then 2. Because a is less than 0, a is negative 3, that's a negative number, my graph is going to look like this. A is negative. My vertex is going to be this point up here. That's the highest point on the graph, so my x is a maximum. I'm sorry, my vertex is a maximum. To find the y-intercept, I'm going to let x equal 0. So when x equals 0, y is equal to negative 3 times 0 squared plus 6 times 0 minus 1, or just negative 1. Did you notice how it ends up being c? So my y-intercept is negative 1. Remember, the y-intercept is where it's going to cross the y-axis. Okay, now I need to make my table of values. Negative 3x squared plus 6x minus 1. And I need to put my vertex in the middle of the chart. My vertex was the point 1, 2. So when x is 1, y was 2. And I need two values smaller. I'm going to go 0 and negative 1. And if you can't picture that on your head, go ahead and look up at the number line. Two numbers to the left of 1, and then two numbers to the right of 1. And I'm going to plug each of those in. So remember, this is going to get a little tricky. I need to do negative 1 squared, which gives me a positive 1, times negative 3 is negative 3. Negative 1 times 6 is negative 6. Minus 1 gives me a negative 10. 0, actually we already did 0. That was our y-intercept. 0 plus 0 minus 1. That's going to give me the point negative 1. Already did my vertex. Don't have to do that. Now let's plug in 2. 2 squared is 4. 4 times negative 3 is negative 12. 2 times 6 is a positive 12. Whoops, positive 12. Minus 1 gives me a negative 1. Let's plug in 3. 3 squared is 9. 9 times negative 3 is negative 27. 3 times 6 is 18. Minus 1. Negative 27 plus 18 is negative 9. Minus 1 gives me a negative 10. And again, this is perfect. I'm seeing the symmetry in my y values, which I should. Okay, let's graph this and see what it looks like. Ooh, I don't think I have enough points on here. Negative 1. 1, 2, 3, 4, 5, 6, 7, 8. Oops, I should have used a bigger graph for this one. So negative 10, oops, is kind of down here somewhere. The graph paper you have actually goes to negative 10. And then, oops, I did that to negative 2. It should be right about here. And then 0, negative 1, the point 1, 2, 2, negative 1, and 3, negative 10. Connected. Try to make it not look like a V. These are not absolute value functions. They should look a little bit curvy. Okay? And notice this one is opening down because A was negative. This vertex is a maximum. It's the highest value. So let's state our domain and range. Our domain, our x can be anything. There's the set of all x such that x is a real number. And our range, what can y be? Well, notice the graph is going down, okay, and my highest point right here is where, oh, I think I graphed that wrong. Hold on. I think I got the wrong vertex there. Let's try that again. It should be 1, 2. There we go. Let me know if any of you caught that. Maybe there will be Hershey kisses for people tomorrow. Okay, there we go. The point 1, 2. Now, my vertex is the highest point, is the point 1, 2, and everything goes below that. So none of my y values can be greater than 2. So my range is the set of all y, such that y is less than or equal to 2, because that's where all of my graph is. Now, remember, in the homework tonight, I believe you have 4 that you have to graph, and I want you to do all of these steps right here. All 7 of these steps. The answers will be posted on Moodle, so you can check your work for all of these. And remember to bring your graphing calculator tomorrow, because I'm going to show you how to do almost all of this on the calculator.